Example 5. Find the inverse of f of x equals 3x plus 5 to the power of 2 and determine if the inverse is a function, then state its domain and range. So pause the video, work on this one on your own, then press play to see the answer. So starting this one off, I'm going to switch x and y. So I would get x equals 3y plus 5 to the power of 2. Square rooting both sides, square root of x equals 3y plus 5. But don't forget, when we are the ones introducing the square root, we have to include a plus or minus sign in front because a positive and a negative number when squared gets us the same value. Then I'm going to subtract 5 from both sides. That will leave me with plus or minus the square root of x equals square root of x minus 5 equals 3y. And divide by 3. And now I have my inverse function. Is plus or minus the square root of x minus 5, all divided by 3. My domain here. Now, this one, I am taking the square root of x, and we can only square root values of x that are 0 or anything larger than that, so we need to say that x must be greater than or equal to 0. My range on this one, because of the plus or minus sign in front of my square root, my range is actually going to also be all real numbers, because every time I plug in a value for x, I'll end up getting a positive and a negative version of that, and that's going to force this to span across both the positive and negative side of the y-axis. Also, because of this plus or minus sign, that means every number we plug in, we're going to get two different numbers back out, which contradicts the definition of a function. So this one we would say, no, not a function, or the inverse is not a function. And the reason it's not a function is because of that plus or minus sign. And you're going to notice that that happens every time we take an even root of a number. The next thing we're talking about is inverses and how we can prove two functions are inverses. So if a relation and its inverse are both functions, we call it a one-to-one function. And we can determine if two functions are inverses by finding the composition of each. And that's what we're going to go through next, and that's our last goal for this lesson. So if you compose the two functions into one another, and they both simplify down to x, that means the two functions are inverses. Because inverses means that those operations are undoing one another, and it's just bringing you down to x with both of them. So let's go through an example of this. Determined by composition, and notice that in my instructions, I'm not saying find the inverse. I'm saying determine by composition. So I'm looking for a specific process here, whether the functions are inverses. So we have f of x equals 3 times x minus 1 squared, and g of x is the square root of x over 3 plus 1. So the first thing I'm going to do, and I'm going to move my myself up there. Okay, so the first thing I'm going to do is I'm going to find f of g of x. So I'm going to take this entire function of g and substitute it in to my x variable in the first equation. So 3 parentheses instead of x, I'm going to write in function g, square root of x over 3 plus 1, finishing writing the rest of function f, minus 1 and squared. Now I'm going to begin simplifying. The plus 1 and minus 1 just gives us 0, so that cancels out. I'm left with 3 parentheses square root of x over 3, close parentheses squared. Square rooting and squaring are inverses, so those cancel. So I'm left with 3 parentheses x over 3. And when you multiply a fraction by its denominator, that cancels, and it leaves us with just x. So we've done this the first way, plugging g into f, and everything cancels out and simplifies down to just x. Oops. Now we have to then do it the other way. Oops, here we go. So now I'm going to take function f and plug it in and substitute it in for x in the other function. So I have to do g of f of x. And yes, you do have to do this both ways. You can't just do it once. So writing out function g, I have the square root, but instead of writing x, I'm going to substitute in function f. So 3 parentheses x minus 1 squared, finishing out writing function g, which is dividing by 3, and then plus 1. 3 divided by 3 with that fraction cancels out, leaving me with the square root of x minus 1 squared, and then plus 1. Squaring and square roots are inverses, so I have x minus 1 plus 1. Minus 1 plus 1 is 0, so I'm left with just x. So I can say, yes, that they are inverses. All right, and that was our last example problem. So we are all done with the 6.6 lesson. Please let myself or Mr. Brasser know if you have any questions. Thank you. Have a great day.